One question, two views. You decide.
Welcome back to The Explainer. For this You Decide Explainer, we're jumping into a really fascinating puzzle from our Easter Island series. Now, as always, we're not here to tell you the answer. Our job is to lay out the best arguments on both sides of the issue. After that, it's up to you. So, the big mystery we're unpacking today is this. Could those massive, iconic Moai statues have realistically been, well, walked upright all the way from the quarry to their final resting places? All right, so you've basically got two competing camps. First, there's the walking view. This theory suggests teams used ropes to rock the statues from side to side, shuffling them forward step by step. Then you have the sledge view, which argues they were laid flat on their backs and dragged over land on giant wooden sledges or log rollers. And the implications of each method change dramatically when you start thinking about the scale involved. And that brings us to the core question for this explainer. Which method actually gets more efficient or more practical as the statues get bigger and bigger? We're going to see how each side makes its case by looking at three key arguments. Okay, let's get right into it. Our first argument is all about force and energy. We're talking pure physics here. Just how much harder does it actually get to move one of these things as its mass goes up? So right out of the gate, what's really fascinating is that the two views are in complete opposition. It's a total flip. The walking view claims that as the statues get bigger, the process actually becomes more energy efficient. The sledge view claims the exact opposite, that efficiency just plummets. So how can that be? Well, it comes down to the underlying physics. The walking view is based on the idea of a pendulum. Think about it. The speed a pendulum swings doesn't depend on its weight, just the length of the string. So a massive 80-ton Moai would rock at the same rhythm as a 4-ton one, but it would store a whole lot more energy in each swing. The crew just has to keep it rocking, and gravity helps pull it forward. The sledge view, on the other hand, is a simple fight against friction. The heavier the statue, the more friction there is, and the more force you need to pull it. Pretty straightforward. So the consequence of this is huge. For the walking view, the effort required doesn't scale 1-to-1. Doubling the weight of the statue does not mean you need double the force. But for the sledge view, you've got a double whammy. Not only does the pulling force increase directly with the weight, but you hit a second, much bigger problem. The wooden rollers themselves would start to get crushed, deform, and ultimately just fail under the incredible pressure of a giant statue. All right, so let's move on to our second argument and see how this builds out. Now we're looking at risk. What does failure look like for each method? Especially when the stakes get so much higher with the bigger statues? And importantly, can you even recover? Before we compare, we have to touch on a quick physics concept, moment of inertia. It sounds complicated, but just think of it as an object's laziness when it comes to spinning or tipping. It's way harder to tip over a heavy, solid fire hydrant than it is to tip over a tall, skinny lamp, right? That resistance to being tipped is its moment of inertia. And this is where that idea makes a world of difference. The walking view argues that there's really only one catastrophic failure mode: the statue tips over. But because of inertia, the bigger statues are actually more stable and much harder to tip over by accident. The sledge view, though, sees a whole different set of risks. As the statue gets heavier, you're not dealing with just one risk. You're dealing with tons of them, and they all multiply. You've got more ropes that can snap, more rollers that can get crushed, and a wooden frame that could just break. And this is really the core of the safety argument for walking. The idea is that all that extra mass and inertia acts like a natural stabilizer. It smooths out the rocking motion and makes the statue less vulnerable to little mistakes from the crew or bumps in the road. The system, they argue, gets more robust as it scales up, not more fragile. Now, in complete contrast, the sledge view sees size as a major liability. The more weight you add, the more likely you are to have a cascade of failures. Imagine one rope snaps. All of a sudden, its load gets transferred to the other ropes, putting them under incredible stress. Then maybe another one breaks, and then another, until the whole system just collapses. So the trade-off here is pretty stark. With the walking method, if it falls, it's game over. That's catastrophic, and you're not just picking that statue back up. But the argument goes, that fall becomes less and less likely with the bigger, more stable statues. For the sledges, sure, you can probably fix a broken roller or replace a rope, but when the statues get huge, you'd be doing that so often, burning through so much wood and rope, that the whole transport just becomes practically impossible. For our final argument, let's talk about control. I mean, moving a multi-ton giant is one thing, but how do you actually steer it? How do you manage it? And does that get easier or harder as you scale up? And yet again, we see a complete opposition of ideas. The walking view claims that bigger is actually better for control, giving the crew more stability and more time to react. The sledge view, on the other hand, claims that scaling up turns a manageable job into an absolute nightmare, basically like trying to steer a runaway freight train. The logic here is really interesting. From the walking perspective, a larger statue swings more slowly, more gracefully. This gives the crew a bigger window of time to apply their pulls and stay in sync. That high inertia we keep talking about just smooths the whole thing out. But for the sledge view, that same inertia is the enemy. It makes the statue resist any change in direction, so steering requires enormous force. And trying to break that thing on a downhill slope, that's a huge challenge. And of course, the terrain makes a huge difference. A rocking statue can adapt and pivot over uneven ground, almost like a person walking would. A heavy sledge, however, would have its rollers get jammed by rocks, or it would create these deep, destabilizing ruts in soft earth. It would basically require a perfectly prepared flat road, which is a massive construction project all on its own. So, to wrap this all up, we asked, which of these transport methods scales better as the statues get bigger? And we looked at 3 key arguments: force and energy, failure and recovery, and control and stability. As you can see, these 2 views are diametrically opposed on every single point. The walking view argues that as you scale up, the process gets more efficient, more stable, and more controllable. The sledge view argues the exact opposite, that scaling up leads to inefficiency, multiplying points of failure, and serious control issues. Both sides have now been presented, and this is where we turn it over to you, because this channel doesn't take a position. So what's your take? Based on these arguments about scaling, which method do you find more compelling? Let us know which view you're leaning toward in the comments. And if there's another question you'd like us to explore next, be sure to tell us below.